Students, I am Rohini Chogle. Already in previous classes, we discussed about Thevenin's theorem and Norton's theorem and also problems based on both theorems. In this class, I want to discuss about superposition theorem. See, students, this is also important theorem for your exam purpose. Okay, let us start with the statement. So, what do you mean by the superposition theorem? The statement is the superposition theorem may be stated as in any linear network containing linear impedance and energy source, the current flow in any element is the vector sum of the currents that are separately caused in that element by each energy source. Here, in any linear containing linear impedance and energy sources, here these are the energy sources and these are the impedance. Z1, Z2, Z3 are the impedance. So any linear network containing energy sources and the impedance, the current flow in any element is the vector sum of the currents that are separately caused in that element. Here the current flows in this element is the vector sum of the current that are separately caused in that element by each energy source. So here this is about the statement. So what do you mean by the statement? In any linear containing linear impedance and energy source, the current flow in any element is the vector sum of the currents that are separately caused in that element by each energy source. So the current flows in any element is the vector sum of the currents that are separately caused in that element by each energy sources. This is about statement. Okay, now we have to prove this statement. Okay, see here, consider figure 1. Say this is figure 1, 2 and 3. So consider figure 1 contains two voltage sources. Here these are two voltage sources, E1 and E2 are the two voltage sources, and linear impedances Z1, Z2, Z3. Z1, Z2, Z3, these are the linear impedance, and internal impedance Z01 and Z02. Z01 and Z02, these are the internal impedance. Figure 2 and figure 3 represents the equivalent circuit to prove the superposition theorem. See, students, already we know by proving Thevenin's theorem and Norton's theorem also we have the circuit. Okay, whenever we prove the circuit, we must and should draw the circuit diagram, that is necessary. So these are the circuit diagram. So first you have to draw this circuit diagram and explain the terms. Means what? This is figure 1 and figure 2. So these are here two voltage sources are there, E1 and E2, and Z1, Z2, Z3 are the two internal sources, and Z01 and Z02 are the internal sources of the figure 2 and 3 internal sources. Okay, and figure 2 and figure 3 represent the equivalent circuits to prove the superposition theorem. Okay, now see here. In figure 1, this is figure 1. In figure 1, there are two mesh. These are two mesh. One mesh, first mesh and second mesh. Active mesh and passive mesh. All of you familiar with the mesh. Okay. These there are two mesh. Let I1 be the current in mesh ABEFA. See here, I1. This is the current flow through the first mesh. So the first mesh is what? ABEFA. This is the first mesh. So I1 is the current flow in the first mesh, and I2 be the current in mesh CBEDC. So here I2 be the current flowing through second mesh, that is BCDEB. Okay. Next, applying Kirchhoff's voltage law to the mesh ABEFA. So apply here Kirchhoff's voltage law. So that is what Kirchhoff's voltage law means. What? In each theorem means Thevenin's, Norton's, superposition. All these theorem based on Kirchhoff's voltage law. So that's why in first video only I explained about Kirchhoff's current law, voltage law, what to mean by the best junction, mesh junction, and basic definitions. In that, what to mean by the Kirchhoff's voltage law, the incoming current is equal to total outgoing current. So that's why I1 Z1. See here, the current flowing through here is I1. So that is I1 Z1 plus. Next, here means what? I1 Z01. Okay. Next, plus I1 plus I2 Z3. Here means what? Sir, current flowing through first mesh is I1, here I2. Okay sir, current is flowing like this, so means what? First I1 Z1, here I1 plus I2 Z3, here what? I1 Z01, that is equals to E1, that is equals to E1. Clear? Next here, I1 Z1 plus I1 Z01 plus I1 Z3 plus I2 Z3, that is equal to E1. Now take I1 common, remaining terms means Z1 plus Z01 plus Z3 plus I2 Z3 equal to E1. So consider this as equation 2. Now applying Kirchhoff's voltage law to the mesh CBEDC means what? CBEDC, this is second mesh. So apply Kirchhoff's voltage law here. Here means what? Here current I1, here I2, means I2 Z2 plus I2 Z02. Okay, next here what? Current is I1 plus I2 Z3, that is. Okay, so current is flowing like this. Here also current is flowing like this. So all terms becomes positive, that is equals to E. Okay, now solve this equation, means what? I2 Z2 plus Z02 I2 plus I1 Z3 plus I2 Z3, that is equals to E2. Next I1 Z3 plus take I2 common, remaining term is what? Z2 plus Z02 plus Z3 equal to E2. Consider this as equation 2. So in first mesh, that is equation 1, in second mesh, that is equation 2. Now solving equation 1 and equation 2 by using cross multiplication method. See, here long terms are coming, means we have to solve this by using matrix method. That's why I1, I2, I3 is not there, that's why 1. Here I1 terms, here I1 terms are Z1, Z01 plus Z3, Z1 plus Z01 plus Z3. Next I2, next term is what? Z3. This is what? Sir, here I1 terms means Z3. Next I2 terms is Z3, and here Z2 plus Z02 plus Z3. Okay, next here 1 is there, first one E1 E2, 1 E1 E2. The value of I1 and I2 can be found from, sir, now we want I1 and I2 value, so that's why first say I1 divide by, okay, I1 divide by what? Sir, this and this, means what? E1 E2 Z3 Z02 Z2 and Z3, means what? We want I1, so leave this row and this column, so that's why first take I1 divide by, leaving this column and this row, means here Z3 Z02 Z2 Z3, that term is here. Next E1 E2, that is E1 E2, that's equals to I2, so leave this column and this row, where that term is there, no, so leave that column and that row, means what? Z1 Z01 Z3 is there, so E1 E2. Okay, now 1 divide by, here E1 E2, this is also E1 E2. Okay, so that's why Z01 plus Z1 plus Z3 is divided by Z3, Z01 plus Z1 plus Z3 divided by Z3. So here Z3 Z02 plus Z2 plus Z3, that is here. Okay, because why? E1 E2, here also E1 E2, that's why. Next, where delta Z equals to, delta Z means what? This is what? Denominator. Delta Z means, consider this as only one terms, means Z01 plus Z1 plus Z3 Z02 plus Z2 Z3. This term is there, no, so write as it is. Next I1, we want I1, so I1 equals to this term divided by delta Z. Here divide by I1 is there, so we want that I1 means delta Z is here, so delta Z E1 E2 Z3 Z01 plus Z2 plus Z02, this is, make correction here. Okay, sorry, this term is indicated as delta Z only. Okay, so here this term means what? This term is delta Z. Okay, so we want I1, so that's why I1 equal to, here I1, that is equals to E1, E2, Z3, Z02, Z2, Z3. Here I1 is there. We want I1. That means what? This denominator becomes numerator and divide by delta Z. Simple mathematics is there. Next I1 equals to E1. Okay. Next this term Z02 plus Z2 plus Z3 minus E2 Z3. So this into this minus this into this. Matrix method. Divide by delta Z. Consider this as equation number 3. Clear now? Now I2. Similarly I2 here also like that. This term is there no, so write it is Z01 plus Z1 plus Z3. Z3 E1 by E2 delta Z. I2 means what? This into this minus E3 into Z3 into E1 divided by delta Z. Consider this as equation number 4. Now, applying Kirchhoff's voltage law to the circuit of figure 2, we obtain the similar equation 3 and 4 by putting E2 equal to 0. See here, I1 dash and I2 dash we want. So, apply Kirchhoff's voltage law to the circuit of figure 2. See here, figure 2, here it is figure 2. See here, it is figure 2. So, apply Kirchhoff's voltage law here. Similar to equation 3 and equation 4 by putting E2 equal to 0. See here. Same as it is. But when we put E2 equal to 0, those terms are directly I1 dash. Here I1 we get this equation. So I1 dash means what? E1 as it is Z02 plus Z2 plus Z3. But put E2 equal to 0. Why we put E2 equal to 0? See here. Here E2 equal to 0. E1 is there but E2 is not there, means that E2 equal to 0. Here current is I1 dash, I2 dash. Here this is what? First mesh, second mesh. Using this circuit we find I1 and I2. So now in figure 2 we can find I1 dash and I2 dash. By similar only apply Kirchhoff's voltage law. Already we applied here. So write last equation only, but whenever E2 is there, so here E2 is not there. So that's why write E2 as a 0. That means what becomes I1 dash equal to E1 EZ02 plus EZ2 plus Z3 divided by delta Z. That is equation 5. I2 dash here. E2 0 means this whole term becomes 0. Remaining terms means minus E1 Z3 divided by delta Z. That is equation 6. Now, applying Kirchhoff's voltage law to the circuit of figure 3. Figure 3. Now, we have to apply Kirchhoff's voltage law to the figure 3 here. Figure 3, we obtain the mesh current by putting E1 equals to 0. See here, in this circuit, E2 is not there. That's why E2 is equal to 0. In this circuit, E1 is not there. That's why E1 equal to 0. So, E1 equal to 0. That means what? I1 double dash equal to I1 we know. So, put E1 equal to 0. Remaining terms is minus E2 Z3 divided by delta Z. So, that is consider equation 7. I2 double dash equal to this E1 terms becomes 0. Remaining term is what? E2 Z01 plus Z1 plus Z3 divided by delta Z. So, write as it is and consider that as equation 8. Now, to prove the superposition theorem, add equation 5 and 7. See here, add equation 5 and this equation 7. This is I1 dash, this is I1 double dash. So, E1 Z02 plus Z2 Z3 divided by delta Z minus, here plus into minus is minus, E2 Z3 delta Z. Okay, that means what? E1 Z02 plus Z2 plus Z3 minus E2 Z3 divided by delta Z. That is equals to I1. So, I1 is nothing but I1 dash plus I1 double dash. Add equation 6 and 8. I2 dash plus I2 double dash. See here. Equation 7 and 6 and 8 minus E1 Z3 divided by delta Z. This term as it is E2 Z01 plus Z1 plus Z3 divided by delta Z. So I2 dash plus I2 double dash equal to E2 Z01 plus Z1 plus Z3 divided by delta Z plus E1 Z3. That is what? I2 dash plus I2 double dash equal to I2. Hence the theorem is proved. See here students, this is simple theorem. Already we know this circuit. Using this circuit only we have to draw two equivalent circuit. Two equivalent circuit means what? In figure 2 only remove E2 becomes 0, only E1 is as it is. In third circuit diagram, remove E1, E2 as it is, so E1 is 0. So apply here Kirchhoff's voltage law in this mesh and the second mesh. Okay, so using matrix method, cross multiplication, solve and get the value of I1 and I2. Now you know the value of I1 and I2. See, current flowing through this mesh is I1, this mesh is I2. Here I1 dash, I2 dash, I1 double dash, I2 double dash. By seeing this circuit only, we understand what we have to prove. I1 is nothing but I1 dash plus I1 double dash. So I2 is nothing but I2 equals to I2 dash plus I2 double dash. Okay, so this is matrix multiplication easy. Already in your mathematics you solved many more examples based on this matrix method. So first I1 as it is, so leave this column and row, write remaining terms. Similarly I2, now write 1 divide by this one. Next consider this as a delta Z, this is delta Z. So I1, so this is I1 equals to this term become divide by delta Z. So solve this equation, and here I2 equal to this much, and using equation 2 put E2 equal to 0, and using figure 1 put E1 equal to 0 and solve the equation. You will get I equals to what? I1 dash plus I1 double dash equal to I1, I2 dash plus I2 double dash equal to I2. This is the theorem of superposition theorem. Okay, proof of superposition theorem. Now I want to discuss about the problems based on superposition theorem. See here, use the superposition theorem to find the current in 1 ohm resistance. Here, in exam also they were clearly mentioned. What? In exam also they were clearly mentioned using superposition theorem or using Thevenin's theorem or using Norton's theorem. So whenever they ask corresponding theorem, you have to solve that problem using that theorem only. So here mentioned superposition theorem. This is the circuit diagram. Okay, now let us see the proof. To find the effect of 5 volt cell short circuit the 10 ohm cell, figure A. This is 10 ohm battery. These are the resistance. Circuit is now equivalent to that shown in figure B. The equivalent resistance of 2 ohm and 1 ohm in parallel is, see here, 2 ohm and 1 ohm. These R1 and R3 are parallel. So whenever the resistance are parallel, in your second PUC already you learn. Whenever two resistance are parallel means R1 R2 divided by R1 plus R2. So 2 into 1 divided by 2 plus 1. That becomes 2 by 3. Now the equivalent of this is series with 3 ohm. See here, these are parallel. So R1 R3 parallel with series R2. So that's why 3. This R2 is 3. 3 plus 2 by 3. That becomes 11 by 3. 3 3s are 9. 9 plus 2 11. So 11 by 3 ohm. Okay, that is resistance. Now see here, remove first what? E1 or E2, anyone. See here, if suppose you are confused, then see, if 2 EMF or the 2 batteries are there means that is superposition theorem. So first we have to remove any one battery. So remove first 10 volt battery. Remaining circuit is what? The remaining circuit is as it is by using your proof only. So 2 ohm, 3 ohm, 1 ohm, 5 ohm, 5 volt. Consider this as figure A. Now see here, these two are parallel. So draw the resistance parallel. Plus this is series 5 volt as it is. This is figure C. Now the current drawn from the 5 volt cell is, see here, the current drawn from the 5 volt cell, that is what? 5 volt. The current I equals to what? E divided by R. So see here, E means what? 5 volt divided by 11/3. This is parallel resistance. So E divided by R, 11 by 3, that becomes 15 by 11 ampere. This current divides between the 1 ohm and 2 ohm branches. Therefore current through 2 ohm due to the 5 volt cell is, here, I1 equals to 15 by 11. We know 15 by 11 is there into, here, these are parallel. So that's why 2 divided by 2 plus 1. Why it is 11 by 3 here? I equals to what? E by R. E is 5 volt. Already these two are parallel with series 3. Already we solved this. We got answer 11 by 3. So that is 5 divided by 11 by 3. That is 15 by 11 ampere. Now I1 equal to 15 by 11 means current flow throughout these resistors into parallel resistor, that is 2 divided by 2 plus 1. That becomes what? 10 by 11 ampere. Now to find the effect of 10 volt cell, short circuit the 5 volt cell, get the circuit in figure B. See here, short circuit this 5 volt battery, then we get the figure B. This is figure B. Means what? Now short circuit this 5 volt, remaining voltage is 10 volt. That is 10 volt. The circuit is equivalent to that shown in figure B. The equivalent resistance of 3 ohm and 1 ohm in parallel is, see here what? 3 and 1, these two are parallel. So consider these two are parallel. 3 into 1 divided by 3 plus 1, that is 3 by 4 ohm. The equivalent resistance of this with 2 ohm resistance is series. That is what? Here 2 is the series. So 2 plus 3 by 4. 2 4 is 8. 8 plus 3 is 11 by 4 ohm. Now consider here 10 volt battery is there. So this is 2 ohm resistor. These 3 and this 1 ohm is parallel. So draw this as figure B. Therefore current drawn from the 10 volt cell, that is what? 10 divided by this 11 by 4, that is 40 by 11 ampere. This current is divided between the 3 ohm and these two resistors. Therefore current through the 1 ohm resistance due to the 10 volt cell is 40 by 11 as it is into 3 divided by 3 plus 1, that is 30 by 11 ampere. Total current through the 1 ohm resistor is, now we want total current through that 1 ohm resistor. So that's why, see, they were asking current through the 1 ohm resistor, means first take 5 volt battery and these two are parallel. Okay, whenever we are taking 10 volt battery, that time these two are parallel. Okay, so we want I1 plus I2. So that means what? 10 plus 11 divided by 30 plus 11, that means 40 plus 11 ampere, that is 3.644 ampere. This result could have been got by directly using I1 plus I2. Already we know this formula. R2E1 plus R1E2, R1R2 plus R2R3 plus R3R1. So R1 equal to 2 ohm, R3 equal to 3 ohm, R3 equal to 1 ohm, E1 equal to 10 and E2 equal to 5 volt. So using this value, substitute in this values in this equation, we got direct answer. But this is short answer. Okay, this is in short form. So better try to solve in this manner only. I just give the example, means what? Using this formula also we can solve the above problem. Okay, see here what we learn in this in this class, superposition theorem. So what do you mean by the superposition theorem? The superposition theorem may be stated as, in any linear containing linear impedance and energy sources, the current flow in any element is the vector sum of the currents that are separately caused in that element by each energy sources. These are 3 diagrams. So this first mesh, second mesh, E1 and E2 both E's are there, means that is superposition theorem only. First mesh, second mesh. What we have to prove here? First, draw this another equivalent diagram. Remove this E2. Okay. In another equivalent diagram, remove this E1. Okay. And the current is I1 dash and I1 double dash. So we have to prove I1 equal to I1 dash plus I1 double dash. I2 equal to I2 dash plus I2 double dash. So apply Kirchhoff's voltage law in this mesh and this mesh. We got some two expression. We have to solve those expression using matrix method, I1, I2 and 1. Sorry, this is not matrix method. This is cross multiplication method, I1, I2 and 1. Okay, write this term and we have to solve I1 and I2. That's why whenever we take that value, so leave that column and that row, write the remaining term and consider this as delta Z. We want I1, so I1 equal to, write this term divided by delta Z. Okay, and this and this minus this and this, consider that as expression 3 and expression 4. Similarly, apply Kirchhoff's voltage law, figure B, and put E2 equal to 0 and consider that as equation 6. 5 and 6. Similarly, apply Kirchhoff's voltage law in figure 3 and put E1 equal to 0. That we will get 7 and 8 expression. Now I1 dash equal to I, we want I, that's why I1 dash plus I1 double dash we have to do. Okay, next I2 dash equal to I2 double dash, that is equal to I2. So I1 equal to I1 dash plus I1 double dash, so I2 equal to I2 dash plus I2 double dash. Hence we prove the theorem. Whenever they were given the example 5 volt and 10 volt, in that we have to use only superposition theorem. See here, first take this mesh, means what, 5 volt, 3 ohm and 1 ohm is there. In that 2 ohm is also there. When we are using 5 volt, that time 2 ohm and 1 ohm are parallel with series 3. So solve that resistance. And next 2 ohm and 1 ohm series with 3. So that's why I equal to E divided by R. Already R we know, and E 5 volt, 15 by 11. So we want I1. So that's why this is what E into, okay, E into the current flowing in this parallel resistance, that is what 2 divided by 2 plus 1, 10 by 11. Similarly in this mesh also, see here, whenever we are taking 10 volt, in 10 volt, that time what will happen, 3 and 1 becomes parallel. Here 2 and 1 become parallel, here 3 and 1 become parallel. Similarly, solve resistance here. Parallel means 3 into 1 divided by 3 plus 1, that is 3 by 4. Series with 2 means 11 by 4. So E equals to I divided by R, 40 by 11. This into current flowing in parallel, that means 3 divided by 3 plus 1, 30 plus 11. So this plus this, that becomes 3.66. Okay, otherwise direct answer means I1 plus I2. See, this is I1. Okay, this is I2. I1 plus I2 means what? E2 Z3, E1 Z3. Okay. I1 plus I2. See here, in this theorem, we just got I1 and I2 in this manner. Okay, whenever we solve these two answer, means I1 plus I2, when we will do, that time we will got this expression. Okay, so using this expression, put these values in this expression and we will got the same answer. Okay, but this is shortcut method. Don't use this method. Okay, use this method only. But remember this method. Okay, this is also important. Okay, so this is a superposition theorem, and problem based on superposition theorem is over. Next class I want to discuss about the maximum value theorem. Maximum value theorem and problems based on that theorem. And one more class I want to discuss about the problems based on Thevenin's and Norton's theorem. Okay, see students, try to solve these theorems and problems. These are very important and these theorems are not getting easily. Okay, so try to understand and try to solve once or twice, you will get understand. If you have any doubt, contact me. Okay, thank you for attending this class.